Honorable admiration to the family. Welcome to 2MRO on 3MP TV, Lotus Television, also known as The Tube. That's right, bringing something new for the family. And of course, this is going to be focused on maintenance repair overall, maintenance repair operations, and mine manufacture and mass produce, or just mine manufacture and mass produce. Now, for a while, I felt really that there's really nothing else to talk about. Now, in my quest in putting this together, I found a couple of things that were very interesting that were definitely a future for everyone. Something that really is a solution. So, we are now tuned in to the #1 investigative primordial empirical research channel on YouTube, Lotus Television. I am your host, Lotus, founder of the Black Lotus Civilization broadcast and Blog Talk Radio. Tonight on Lotus Television, we will continue to investigate out of the Renaissance into the Royal Society. We will be focusing on a part of the Renaissance and Royal Societies, manufacturing. But we have to start from the beginning, as it is mine, manufacture, mass produce. We have to start with mining. So what we're going to deal with, mining, how things are made, and variations of other things. So this show will stream daily for the benefit of our species and progress of our greatest grandchildren to come. What I have set in motion for everyone is self-evident and profound. The fact that mine manufacture, mass produce will lead the way, and this is how it will lead the way, with printed technology. That's right. Printed technology has taken 3MP to the next level. 3MP has always was a plan to remove labor force by creating machines to handle our daily tasks. With honorable admiration to the 5,000 elite, Olmec Nation, Aboriginal Movement, honorable admiration to Brother Lex Vortex and the Vortex Media, and how we have it. So, this is something I have planned for a while. And the project that I have attached to this is the Marasas da Kehe project, which is an acronym for major appliances, domestic appliances, small domestic appliances, consumer electronics, and home electronics. Now, major appliances and domestic appliances. Parts of real estate, large machines, housekeeping, cooking, laundry, food preservation, plumbing, fixture, refrigerators, and washers. Small appliances and small domestic appliances, consumer electronics, and home electronics. Semi-portable machines and portable machines, tabletops, countertops, platforms to accomplish household tasks, microwave oven, toasters, humidifier, coffee maker, TVs, DVD player, video games, remote control machines, telephones, cell phones, computers, printers, and paper shredders. The introduction of industrial 3D printing machines will result in mass production of civilization, and machines replacing customer service jobs will result in a chance for ecological reversion. Nanotechnology, solar technology, and free energy is the future. The future may be late, but it's always on time. With the right motivation, innovative guidance, we can secure endless possibilities and explore countless practical applications by gathering all metals, no matter where it is, and performing the process of bullying with efficient modernity. Before the task of geosurveying high-quality deposits for rich minerals, we can establish let's just say a city. We can build a city in less than a month. Now, this is really going by step, but this is really step 4 that also involves step 2 and 3. Step 1 is frequency plus sound equals color, which I will be bringing in. Then we have what we have today, which is 2MRO on 3MP TV. First step, frequency plus sound equals color. Second, 2MRO. Third, 3MP. Fourth is GDBD4. That's geodynamics and biodynamics. Now, this will be more for the philosophical and theological, let's just say, social paradigms, and you can say even religious understandings or spiritual understandings, but more for a primordial approach to it, along with all the advances and innovations of today. Now, for that, for GDBD4, that will be a discussion for another time. Today, the focus is 2MRO and 3MP TV. Now, for GDBD4, the project for that is Go Beho project. That's geodynamics, oceanography, primordial ecological consumer organics, biodynamic engineering, and holistic organics, such as herbs, roots, algae, and even tree bark. And when we deal with that, we will be going over anything and everything connected to geodynamics and biodynamics. Okay. I picked a late night. Been dealing with life. You know how life is. So, just working things out, getting stuff in order. One of my family. And I stumbled across an idea to do a show tonight. Originally, I was not going to do this tonight. I was going to wait till tomorrow. But, decided to do it tonight. Hopefully the family will appreciate the information that is going to be revealed tonight. Again, the focus is going to be mining. Mining and how things are made. So we'll be dealing with how things are made, considering household products, not just how things are made, but the mineral content and how it's made, what it takes to make these things so we can make these things. I know many were caught off guard by the information of 3D and 4D printing. And that's due to the fact that it will affect so many different occupations in America. It's gonna change everything, really. Now, innovations in this technology means that it will be able to produce massively, mass produce. So they have 3D printing machines that print 3D printers. Come on, y'all. So these chances to grab a hold of this now before it is too late, you don't want to grab a hold. You want to grab a hold of this now instead of waiting. And this is a tool, by the way, for the 5,000 elite, that we can actually build cities now. So we have to start with a street, laying the foundation for one street. We have to have the knowledge to do these things. But having the capability of building a house in 24 hours changes everything. It changes everything. And then the advancements and innovations in that technology is exceedingly mind-blowing. Exceedingly. But we have to start with the basics, because we can't just get to the mass production without mining and manufacturing. So I decided to really release the 3D printing, 4D printing, which is already out there. The information is obviously, available to be watched on YouTube. It's accessible, and it's even, you can buy the machines, but no one is taking advantage of it. And I think that this should be our focus. This, free energy and solar panels. We have 3D printing machines that can print what we use for free energy. And we have 3D printing machines that can 3D print solar panels. Hey, baby, how's it going? Live streaming right now, so one moment. One moment. Hold on, y'all, one moment. Apologies for the interruption. Throw some little music in and you edit. Let's see what's going on with the chat before we get further into this. Not much. One viewer in the building. That's what's up. Oh yeah, I have to. Let me do it right. This is 2MRO on 3MP TV, Lotus Television, the Tube. That's right. Welcome to the Tube. That's the reason why I call it that. So I will show. So this will be a what do they call it? Blow the horn, whatever it is that they play for some type of something new coming this way, some type of new music or whatever. Okay, let me put it on there. All right. Excuse me. Okay. And this is basically an introduction for tomorrow morning's show. So I'm just going to show, some mining videos from my Matthew Craig channel and how it's made. Also, our brother Vortex Media is live streaming right now as well. The brother has The Spirit World. Is it real or is it just spookism? Very interesting topic. Okay, let me get to my video for the family. Apologies, family. I should have had this up already. I'm working on that. I got it. Got it. I got a little adjustments to put on to that. Just showing a little sneak preview. I don't know, drop the horns for one of the new introduction videos. Got a whole lot of stuff in store that I'm putting together, so the show will start to be ran as professional as possible. Let me check it out. Good, we got 2 viewers in the building. What's good? Yeah, he did. He sure did. Got brother Root Words in the building. Yeah, man. I had to throw that clip on there. You know, now I had to change it up too. Lotus Television, I had to throw the tube on it. Had to. You know. Now I want to get it started. Got to get it started right. So let me get back to the screen share. Let me get to this first. Hold on, y'all. Hold on. Here we go. All right. Welcome to 2MRO on 3MP Lotus Television. Now, this industrial 3D printing machines will result in mass production of civilization machines, replacing customer service jobs, will give our species the opportunity for ecological reversion. As said before, nanotechnology, solar technology, and free energy is the future. The future may be late, but it's always on time. Now, we have to stay ahead of the curve. We can ride the wave all we want, but you can enjoy it at the best of your ability when you see it coming and you know what to do when it's here. The thing is, we have to think a little further down the road on these things. Okay, we need to have a set, I guess, a goal set. You have to have a short-term goal, mid-term goal, and a long-term goal. Me personally, I'm one of those for the long haul. You know, I set certain things in motion in 2013 so I could be in a position to do this today. You know, now that's just with that. Things happen. So I really should have had this going a few years ago. But things happen in life as they are today. Now, the whole thing is, if we get in control of these things, now, mining, manufacturing, mass producing everything that we use, if we get in control of that now, if we get in control of nanotechnology, you know, free energy, solar energy, 3D printing solar panels, 3D printing free energy devices. But first, we have to deal with mining. So without further ado, let's get it going. Now, this is just a short history on Ontario, the Ontario government, silver mining. We're going to go through my channel, Matthew Craig, the videos that I stored last year, and I'm going to show you that I've been really putting a lot of effort into this. Now you see these are black and whites from 1904 to 1918, mining in cobalt. Now, the thing is here, I should say it like this. See, the thing is, those are human beings using machines to drill and mine. Okay, so we need to make machines, or we can call it robots, that can do the mining for us. The robot that can take the machine down there and mine it for us. Now, many people watch those Star Wars movies and were just so razzled and dazzled by the dark side of the Force and the whatever supposable good side of the Force, the Jedis versus the whatever we want to call them. But there's a scene where Anakin Skywalker is fighting Obi-Wan Kenobi, and they are on a planet with nothing but lava flowing around, and the machines are doing the jobs. Okay, so we can make all these drones and this drone technology that can pinpoint and tell you exactly where something is. We have 3D printing machines that are 3D printing houses, 3D printing human body parts, human organs. There's no excuse for us not to make a robot machine that can go into these mines and get these things for us. We don't need child slavery, children in the Congo digging up the minerals that they're digging so we can have a piece that makes our cell phone work. And the geo surveying, these things will definitely be looked into as well. We have enough minerals in junkyards. Still to this day, there's areas where you can take metals and get money for it. Well, we need to stop turning our metals in and learn about bullying and smelting and making our own stuff. You bully and smelt whatever minerals you want using a 3D printing machine. That's all you need. Keep it in liquid form. It can be cooled down in liquid form. If anybody has done brick tending in their life, I myself, I've done walkways, done driveways, helped make parking lots, all the whole smelly tar, all of that. I myself have participated in this. Human beings do not need to do these things. Machines need to do these things. Now, by doing that, we can reduce deaths from people mining. And if you notice that there's not a lot of mining going on because everyone has moved over to different forms of plastic and different variations of that type of mineral, that chemical compound of whatever. And there's not so much mining going on. A lot of factories been shut down and most of our jobs have been sent overseas. Well, that's good. Send all the jobs overseas. I'm trying to send the jobs to nowhere. Let the robots work for us. Let the machines work for us. And I have something to say about that too, because everybody might think of all those movies where they made robots, where they gave robots human emotions. These are machines, man. They don't have, your laptop is not going to get up and turn into Voltron or turn into Megatron on you. So they have done these things to keep a people who are very spiritual. I love it that Brother Vortex is talking about that right now, because I'll definitely have something in it to say about this. It almost sickens me because it stopped a great deal of time where we could have innovated and made our own cell phones, our own everything. We could have been making these things, but we're sitting there with the mind state of we don't need to worry about those things, or those things are evil, or the end of the world is coming soon, or if you get too far into machines, then the mark of the beast and stuff is going to be a part of the machine stuff. It's been so many ways to distract us and keep us from doing these things, but yet we are still using all these products, these white goods, these brown goods, and even gray goods, even the deported from foreign countries into our country, things that we buy, and we're not making these things for ourselves. And it's ridiculous. It's really nothing else to talk about. It really isn't. It's nothing to talk about. No more debates. There's nothing to whine about. People upset about whatever knowledge and information is out because computers or whatever. And now that it's not easy to lie, or it's not so easy to trick people as it was 20 years ago. You could trick or dupe or juke somebody like it's nothing. But now with this day of technology, for us to even see all these different ways of securing a solution, a proper solution for our future, where we don't even need to pay attention to the government anymore. We can just move on. The government can see what we're doing and say, whoa, what's going on here? You guys have created your own social economic structure. Let's see how we can apply this to our system. You know, let's do something where the rest of the world looks at us, where we lead by example. Let's stop saying, oh, look at the government, look what they're doing. Oh, look at the police, they're over there killing us and stuff. Let's lead by example. You know, cut the talk, man. Cut the talk, man. Let's do the walk. You see that? They're using electrical engineers, they're using machines to do this, but then they're human beings down there. 1904 to 1918. There's no way that after 1918, for it to go 100 years down the road to 2018, that a human being has to go down into these tunnels and do these things. We need to use machines. Extracting fine grain, high grade ore. This with the rich ore picked from the moving belt receives special treatment. We need to know everything it is to know about that sentence right there. We need to know how to do these things. Fed by gravity, my butt. That's what it's fed by. The ore flows to concentrating tables, which removes coarser metallic portions, then to classifiers, and finally to the tube mills, which grind it to slime. Perfect for 3D printing. You see it? No more debates, man. It's time to be men. Let's be real men. All right, let's step it up. Stop letting everybody else do stuff for us while we sit there and brag about paying for it. You could have been a real man and made it yourself. The silver is now in solution after further treatment to remove foreign matter to concentrate is caught in filter presses. Using concentrates from the presses. This concentrator mud now ready for the furnace is 90% pure silver. Everything we use that got silver in it, there you go. After cooling, the bars are trimmed and weighed, then stored in vaults. Each bar weighs about 70 pounds. That's 70 pounds of pure refined silver. Others, cobalts, porcupines, and let me pause it. Sudberries await discovery in Ontario's vast, unprospective regions. So here it is. I know most want this delivered to them in the most hip hop and all that type of stuff and debating, and this elder said this and this elder said that and all that. That's getting us absolutely nowhere. I'm no longer want to entertain it. Everyone wants to go in the circles. Cool, no problem. Continue to go in your circles and sit and talk about what the Grand Master said until 2058, and the rest of the world will have moved on while you look silly talking about a trip to Egypt, or somebody telling me about all the bad things the government has done, or the conspiracy against the Freemasons and Masons. And it's very interesting that I've been releasing information that's mentioning Freemasons and Masons, but if you'll notice in the content, the way I'm delivering, I'm saying y'all putting them down, but they're responsible for everything y'all stand for. If you're in the Kemetic community and you're putting down Freemasons and Masons, you're ridiculous. And in fact, only person that can really walk around with an Unca Heru or talk about any of that Kemetic stuff or speak meta is someone who is a Mason or a Freemason. Anyone else trying to do it, they're faking it. You know, fraternities don't count. You don't know fraternity and sorority. No, you got to be a Mason or Freemason, because that's the people who made it. That's where it comes from.
4.5 billion-year-old planet, still evolving. As continents shift and clash,
all right, that's not
volcanoes. Earth, a 4.5 billion-year-old planet,
it was that.
Still evolving. As continents shift and clash.
All right, send over Space Now 2015 deepest place on Earth.
The Earth's crust is carved in numerous and fascinating ways.
This is more into the GDBD 4. But just wanted to share a little bit of this. Just the intro.
The Marianas Trench, the deepest point on Earth, is explored. Its sheer walls cut 7 miles into the Pacific Ocean. The mystery of what created this deep, dark chasm takes science detectives on some of the most dangerous dives ever attempted. Deep.
Now, you saw the pressure do that to the machine that they sent down there. But the point is, down here in the ocean, a lot of the minerals have just been pushed up by volcanoes. We can have these machines go down there and scoop it up. Just by studying aquanauts, you can get a greater understanding of the capabilities of not just mining for the minerals that are pushed up by volcanoes in the bottom of these floor beds of the oceans, but also the healing coral reef. You know, things that can heal us, things that can help us in our lives, just by getting down there and getting some coral reef samples and seeing how it affects us, instead of putting all these negative medicines in our body, and which is tearing up the minds of our elders. Between 50 and 80 of our people right now are officially under attack by the FDA and whatever the FDA, the WHO, and pharmacy itself, any of the pharmaceutical companies. They are right now making sure that if you are going to get your retirement, you're only going to enjoy a good 10 to 15 years of it before they force you to spend a big portion of that on drugs from, hey, we need to step it up, man. I'm not going to sit and talk about grandmaster teachers and debating about which organization should do something right, man. Those days are over. or even exposing people, man. No more of these things, man. Let's make some real so let's make some real pace and direction. So while this stuff is going on and people are experimenting, you know, we're gonna sit and continue to bash each other and put out ridiculous philosophical videos. They get the most views because it makes everybody feel comfortable, and they're saying something that you agree with. Well, I don't agree with it. We should be focused on these things. This right here, how to take a microwave apart and make things and do things and innovate. Look at these things, man. I don't want to see a debate. I'd rather see this. I don't want to see no more debates or no more comedic lectures or Kemet versus Hebrew, this or any of that stuff. I don't want to see that. You know, show me how a magnetron works. Show me how you make a magnetron from scratch. This also debunks that radiation nonsense they've been kicking to us about microwaves. That's not what's causing us to have that nauseated feeling if you keep your head too close. It's the mixture of what's going on with those machines. Now look at this. The magnetron was really hot, so he stops it. It's usually cooled with the fan anyway. The circuit works, and that's a good start. That means I can take a microwave apart and do whatever I want. There is no limit to the way I think. I don't have the limit of I have to make it look like an Encore. I have to make sure it has Black Power RBG on the side, or just something that's immediate, that serves no purpose at all. I have no limit.
Hey everyone, I was finally successful in depositing a clear conductive layer onto a microscope slide. So this will be the basis for a lot of my future experiments in OLEDs and other display technologies. So let me show you how I did it. The device that's actually doing the depositing is called a sputter gun, and I machined mine from basic pieces of metal, and I'm going to unscrew it here like this, and eventually the whole thing just comes off like so. And down in the hole here is a spark plug, and it's facing up towards us. So on the underside, there's the rest of the spark plug, of course, and then right next to it, there's a needle valve with a hose coming off, and the hose runs to my argon cylinder. So I can control how much argon is getting into the chamber through the needle valve, and I can get high voltage into the chamber through the spark plug. And the underside of the sputter gun has a rod in here that contacts the top of the spark plug. So I have sort of a shielded entry into the chamber. The sputter gun itself is relatively simple in construction. So let me just take it apart and show what's inside and then describe how the whole process works. So the very outside is called a ground shield, and it slides off like this. And the purpose of this is just to keep the things that you don't want to sputter inside this. So when the shield is on, the only thing that's exposed to the chamber is the surface of this disc here, which is the thing that we want to sputter, to send off onto the microscope slide. So if we take that off, the rest of it is built like this. And between these two layers is an insulator. So we'll take this apart. And currently there's some changes that I'm going to make to this. These are nylon screws and nuts holding it all together, and nylon is not really a great vacuum chamber material. So eventually I'm going to upgrade this, but I'm not quite sure what I'm going to use instead. And so this part is at the vacuum chamber case potential. Let's just call that ground. And then the inner part here, this is where it touches the spark plug. This is all at a negative high voltage, let's say 1,000 volts negative. So inside here, we've got a very high potential between this outer shell and the inner shell, but there's a few other tricks here that allow us to sputter just the target material and not sputter the rest of it. So I'll open this up. And as you can see, I'm missing quite a few screws because I haven't got the right ones in yet, and I just wanted to test this quickly. Inside here is a magnet, a ring magnet, neodymium ring magnet, and a steel pole piece that I turned on the lathe. And so the idea here is that when the magnet is inserted into here like this, there's a nice magnetic field on the top here. And you can even see one that I cracked my disc, unfortunately, so I'm not going to undo the top layer just yet. But also that there's a ring pattern where the disc has been eroded by the sputtering. I've also got some holes in here for a cooling system, which unfortunately I didn't have running yet, so that's hence the cracked disc. And the idea with that would be, this is a sort of a Teflon hose. It's actually called a plastic called PFA with an O-ring on like this. The hose can be sealed up to this, and then with an O-ring in the right spot here, this whole thing closes up and I can actually pump water through the copper block. So a lot of sputtering systems say they require water cooling. And I always, thought that only applied to like systems that ran for, 8 hours a day. I figured that the thermal mass of this block would be enough to keep me safe for a 5-minute run. But as it turns out, not quite. I'm not sure if this was due to my clamping or too much power or something, but I think water cooling is kind of a necessary thing if you want to sputter stuff at any reasonable rate. Okay, so let me tell you how this thing actually works. So if you want to make a nice uniform coating on something, say like a microscope slide, you have a few different options, and two of the most common ones are evaporation and sputtering. So in a previous video, I described the evaporation process. And this entails heating up the material that you want to coat. Heating up the material with which you want to make the coating. And typically that's done in a metal boat like this. So what we do is pass a really high current through here. This thing becomes very, very hot, white hot even, yellow hot. And the material here evaporates and then condenses on the thing that you want to coat. So this is, roughly analogous to boiling water in the kitchen and then noticing water droplets condense on a cold window. The downside with this is that you have to heat up the material to that yellow hot temperature. So if your material can't take it for whatever reason, or if it changes into another material at that temperature, then this isn't going to work. And when we're talking about making conductive ITO coatings, this is definitely the case, where if you heat ITO up in a vacuum, as far as I know, it reduces itself back down to base metals, and it doesn't work. So an alternative process is called sputtering. And this works by accelerating gas molecules and slamming the gas molecules at very high speed into the surface of the material with which we want to make the coating. And when that happens at just the right energy levels, it actually chips off a few molecules of the surface, off the surface of this material, and they go spraying off into the chamber. And eventually they'll land on the thing that you want to coat. So here's a cross-section view of the sputter gun. The ITO disc is the thing with which we want to make the coating. And then we've got our magnetic pole piece here with north and south poles. It doesn't matter which is which, I don't think. The idea with the pole piece being that the magnetic flux goes through the steel and then back up, through here. So the magnetic field lines look like this. This whole intersection here is at about negative 1,000 volts, and the outer section is at 0. So when we pump down the chamber to a very low pressure and put our 1,000-volt potential difference on here, the remaining gas molecules in the chamber will ionize, basically just like they do in a neon sign. And the trick with the magnet is that it concentrates all of the electrons in this area. And it does this because the electrons are relatively lightweight and they have charge. So the moving electrons are affected by these magnetic.
Now here you're hearing a lot of things that I absolutely disagree with. But the fact is, this is something that we can use, all right? Into the sputtering, the process to create clear conductive coatings. It's just for
field
coating.
lines. In fact, they actually spiral around the magnetic field lines. So we concentrated all the
what you have to go through for coating.
However, it's not the electrons that are actually doing the sputtering for us. What happens is these spiraling, fast-moving electrons end up ionizing more gas molecules. And it's actually the gas molecules that are attracted to this negative.
So what I'm showing you here is, and this is just for conductive coatings. You know, let me get to the next video. All right. This is another dangerous magnetron video. I believe I have 5 videos on here.
Видно там его?
Mm-hmm.
We're doing debates. Doing debates, y'all.
Зажигалка. Так, водичку.
Like this is what I used to sit around doing, taking things apart, figuring out how it works, trying to do things with it. Look at that, boiling water.
О, как 5. Блядь, горячо. О! Горю.
Look at that. And that's the magnetron. That's what's in your microwave. Yeah, that shit's. About to bake that potato like that. That's disgusting. But it's showing you, you know, they're being silly, man. But just think of all the other practical applications that we can use with this. And all you have to do is ground it, have a way to where it's not causing harm, to where it doesn't catch on fire and burn and blow up everything. And there are ways to stop that. But this is just another video showing you that we doing debates, y'all. We doing debates, man. People around innovating and creating stuff and multi-millionaires and 3D printing stuff. But we doing debates. We having disagreements.
Okay. Hi, everyone. My name is Michael Scarito, and I'm going to talk to you about how you can build your own radar system. So this talk's a little bit off the wall, I guess. You know, traditionally it's more security focused at DEF CON, but I thought it was a pretty cool topic, and I like remote sensing systems, so I wanted to present something that I've been working on with some people at MIT. So when talking about stuff like this, there's going to be some amount of math. I mean, there's not really any way to avoid that, so I do apologize in advance, but you know, we're going to talk about it, and hopefully I'll explain it in a way that you can understand pretty easily. But I didn't want to, you know, kind of overwhelm anyone with it, so I'll try my best. I agree. So first of all, what is radar? Basically, it's some way of looking at the world through radio waves. You know, you're measuring something, you're sensing some sort of electromagnetic field, and basically what you're doing generally is you send out a pulse and you look at the response. So radar used to be an acronym, it's become a word. It stands for radio detection and ranging, and that's basically what it is. So, what you might think of traditionally is something like, I think that's a weather radar from like the 40s or something. So, that's kind of the basic idea of what people think. But and what you're measuring is essentially position of something, velocity of something, direction of motion of something. But the thing is, you can actually do a lot with this type of technology. You can look at pretty much anything. I mean, you can look at, like, here we got people, terrain, like land surface. You can look at, foliage, weather patterns. You can look at clouds, rain, ships, aircraft, spacecraft, like pretty much anything you can think of. So I'm not really talking about something like this, but what we can do today is more something like this. This is an image of the Capitol. I guess it's a Sandia radar system, but this is what synthetic aperture radar can really do with a nice system. So what we have is a 3D point cloud of the Capitol building taken from an aircraft. So, why do it yourself? Why is this, something that we could talk about now? And the reason that, it's particularly interesting nowadays is because it's become extremely easy to do this, and it's become cheaper than it ever was before to do this. And the big thing was the wireless revolution has given us access to a lot of hardware that used to be really expensive and pretty much only available to the military, but the need for it in the commercial communication space means you can buy a lot of this stuff just off the shelf. And the other thing is, for processing, all this stuff used to be done in analog. Nowadays, you can just feed it into a computer, and the computer will do pretty much everything for you. And I guess, the main reason to do it yourself is because it's pretty cool. You can do some pretty interesting things with it. The stuff that I'm going to demonstrate today, hopefully, is not even close to the extent of what you can do. I just want to give a simple demo of, like, in this space, what can we look at? So who am I? I'm from MIT. I'm an electrical engineer mostly, and the rest of the time I do pretty much anything else, engineering or science related, when I need to. Currently I'm working on RF remote sensing systems, not radar systems, but actually weather instrumentation at MIT. And I have a pretty broad set of interests, but a lot of stuff related to RF technology, including like RFID communication stuff, imaging systems, remote sensing, wireless comm, and security, of course, is a big interest of mine. And anything that can combine those issues is awesome. So I guess what I'm going to start with is talking about how radar works in a general sense. Then I'm going to go a little more detail, like how would you actually make some of these measurements I was talking about with the radar system. After that, talk about how you could build your own radar. Hopefully we can demo it if it works for me. I'm going to go into a little more about synthetic aperture radar, which is basically a technique for taking pictures with radar. And this is both 2D and 3D imaging. And then we'll go into maybe improving the design of a home-built radar, like what sort of stuff I'm looking to do in the future, and what stuff I'd love to see some people here talking about next year if they did it themselves. So first, with an overview. Like I said before, the basic idea is, we transmit a signal and we get some kind of return off of it. So, this is an aviation system. So basically what this is doing is it's spinning around, sending out a pulse, and measuring how long it takes to come back. But it's not necessarily that specific. You could do a lot of processing with that return signal. And the key point here is that every radar system works on this type of principle. You're transmitting a signal from somewhere, or somebody's transmitting a signal from somewhere, and you're looking at how that reflects off of a target. And all this is governed by this thing called the radar equation, which is this big thing with a whole bunch of terms that, there's a whole bunch of stuff here. So basically what we're looking at is the function of received power versus transmitted power. And the way that
it's so interesting that a lot of this, majority of this, almost all of it comes my way because of the technology of diodes and magnetrons. It's very interesting. Something simple as what makes your microwave work. Now, I had many conversations with many people about the disagreements of the technology from NASA and the information and data provided from NASA, being that it's never a true image. And me having information like this, I kind of sat on it because I never felt that it was really important to really share until people started talking about things connected to flat Earth information. And then when I started pulling this information, I always received like challenges. I didn't receive, oh man, let me look into that. It seems to be challenging. And let me say this. If one thinks that they're going to listen to this information, you're going to be able to run out and just go ahead and get some 3D printing machines and just go ahead and do whatever it is. I mean, it's cool. It's fine. But if you try and do it alone, it's not going to work. You're going to need a team. And it takes more than just a little bit of money. My 3MP, Mine Manufacture Mass Produce, GoFundMe is for $1 million. Really should be for $100 million. But just $1 million, because with just $1 million, I could buy the machines to 3D print a house, submarines, planes, you name it. You name it, I could print it. And all we would need to do is 3D print a facility to do it in. 3D printed facility for 3D printers. Start making 3D printers. You know, people want to look. It changes everything. Okay, I'm not gonna play too much of this.
Changes, you know, we got transmitter gain,
but
antenna aperture, which is like how big your dish is. Cross section, propagation factor refers to the medium that you're in.
But this video, build your own synthetic aperture radar, is showing you that we can build these things. We can do these things. Let's stop letting everyone else be responsible for what goes on with us. Now, this is another video. I'm going to play a very short portion.
Hey, what's up, everybody? This is Titan from Titans of CNC.
This is what we need to do, not
the TV series.
Bookstores.
Pulls back the curtains to American manufacturing.
Good to have knowledge and information.
Showing that we can do it better, faster.
But not if you're going to die broke.
Right here.
I want to secure 70 generations.
America. Yeah,
can't do it with a book.
I've been getting a lot of emails.
Can't do it with a debate.
IMTS. You got these guys, young machinists, and they want to build their shops, and they're like, Titan, how did you do it? Like, you know, I got email after email after email of guys saying they're getting machines, that they're buying their own shops. They're making it happen. I also get emails from machinists and shop owners that they might be in oil and oil's down. They're laying off workers. You know, they're going through the hardship, the struggles, and they're like, Titan, you know, how do we get new work in? You know, I can't solve all the problems. You know, I can't fix everything, but you know, everybody knows, like, you know, I suffered through the valleys. I had laid off employees. I almost lost absolutely everything. And after jumping into aerospace and solving those problems, it gave me the passion to look back, to create a show so others didn't have to walk through the same thing. So today, I just wanted to come and just speak from the heart. No big cameras, no big fancy crews or anything. Just me and my phone. I want to talk to you a little bit about, you know, my philosophy on having a job shop. We can do it in a few different segments. Right now, I'll just talk a little bit about marketing. You know, I think what makes me good, you know, I can walk into, you know, $1 billion facility with my t-shirt, with my black pants and my black boots, you know, because I'm a builder. I don't pretend to be anything else. I'm a builder. I'm a programmer. I'm a CNC machinist that solves problems. I'm a programmer. I'm somebody that, because of my mind, I'm able to design fixtures, use Mighty Bytes, use crazy tools to run multiple parts at a time. You know, I always say, like, machining, you know, a lot of people can become machinists, but to go to that elite level, you have to solve problems. You have to figure out how to run 100 parts at once, how to keep the doors closed, where one person can run multiple machines, multitask, you know. We're dealing with a global economy, and we need to think like that. You know, it's not about us. It's about our customers. How do we solve problems? How do we drop their prices? How do we make them happy? You know, we got to be willing to wake up at 2 a.m, jump in our truck, go to the shop and make parts and drive them, you know, 8 hours away if that's what's needed, right? Because we're the problem solvers. We're the CNC machinists, all right? So I do well with my black shirts, my black boots, my black pants. You know, when people see me driving down the street, you know, I got a truck. You know, it's not huge money. It's an 08. It's paid off. It's a beast, though. I got 40s on it. I got my name big. My mom, my sister's name is Athena. You know, my name is Titan. It's my birth name. People always think I made it up. But this business is about reputations. It's about family and industry, right? It's about relationships. And when you do well and you take care of people and you build that reputation, then your name stands for something. That's why you always see my name on everything, so people know that I'm connected.
That's how we have to take this, man. Now, I'm not saying this person's philosophy is the end all be all, because I could play Eric Thomas as well. But the difference is between this person and Eric Thomas, this man is making things that NASA JPL uses. The difference between him and Eric Thomas is the person you listen to when you're feeling down and out while you're doing this, when you're doing something that is working. Okay? Don't listen to Eric Thomas because you're getting ready to go debate. You're about to go have a discussion or a social disagreement experiment. No more. Let's move now. Now, let me see. Hold on, y'all. Hold on.
To it. Titan American built. It's going to change Titans of sea.
All right, it's not showing.
Right?
Yeah, here we go. That's why I wanted to do like
of excellence.
Get in that office.
It
Showing what you're working with.
But people that your style, you guys got to figure out your own colors, the way that you guys do things. But it all matters. So they come into my shop. From the moment they come in, look at this, I'm going backwards. You see my son, my kids, right? Me and my son Tyson right behind me because I got stuff on the walls. Me and my other son, Titan. Me and my son Chris. I've established it's a family business, right? But it's a CNC shop. And yet I got crazy pictures. You walk to the other side, I got filming. What, this guy's filming. He's got crazy big parts, you know? There's my shop right there. They haven't even been into my shop and they're burning it. It hangs proudly in my shop. For the some first thing that you see when you only in America can a guy come from homeland to building a job shop. Because America is the land of the free, and our veterans fought for us for that freedom, and it is proud. A veteran gave me this flag, and it is a prized possession. Because of talent, because of the way I think, because of work ethic and the way I do things, I can have my own CNC machine shop. That shop you see in the back, right? America is amazing. It's great. All religions, all people. It's great. If you have the talent, you can come from nothing and achieve something through hard work. Somebody told me a long time ago, solve people's problems and you're going to do good. And that I've taken that to.
Hear that? Solve people's problems. You're going to do good. Here to bring solutions. I'm not here to dangle a book over your problem. I'm here to say, let's put our fists in the air because a police officer shot somebody. And I'll definitely as I go over Octagon, you know, as I go over the Octagon connected to hold on, y'all, hold on. Yeah, the Octagon. There you go. So going over that, connected to the whole police situation, sitting talking about it, it's not going to solve the problem. Bringing a real solution, that's going to solve a problem. What is the solution? Well, we need problem solvers. We don't need debate makers and the venue and we don't need that. You know, we don't need videos about the breakdown of the latest movie that came out that can tell me all the metaphysical stuff from the movie. We don't need that. We don't need any of those things. We need people who are going to really use their hands and really use their time and their finance to do this. Because if I'm trying to secure 70 generations, you know, down the line from my birth to my death, then if I get somebody else, if I get 70 people to focus on securing 70 generations of their own bloodline, if I get 5,000, like the 5,000 elite, to secure a civilization of people, that's all we need. That's all we need. Because many can't grasp that we can grab a hold of white goods and brown goods. And I'm going to go over that again and explain in details what it is. Now, take a trip in the shop, man. Stop talking. You already don't got brothers in your shop.
You got to sign your name.
I'm subscribed to this person's channel.
Anything, like, we have to know those things.
But this is what we should be doing.
Everything has to be documented, right? Come into the shop.
Not a news van, Signetter.
You got to press a button.
Get a CNC machining
shop. You
shop.
have to be buzzed in.
Get a 3D printing facility. Let's get with the program.
Right when you walk in, I come from Hawaii. Like, it's just a piece of me. Nice saltwater fish tank. That's my boys. I got Nemo in there. I got Dory. You know, I got people's kids come in here and they check it out, you know. But check it out. It's black. Look at my walls. Like I said, you guys have your own style, but have style, have perfection.
There you go.
My walls are black. I got pictures. I got parts everywhere. That's one thing you notice is parts. Right? I don't have to have a Lamborghini in here. I don't make a Lamborghini. I don't have to have fancy things. I make parts. I'm a builder. I'm a machinist. I'm a maker.
You hear that? I don't need to have a Lamborghini. I don't make Lamborghinis. We have to have that mind state. You want a Lamborghini? 3D print your Lamborghini.
I made that table.
3D print
everything. Those
3D printers that 3D print Lamborghinis. Let's make these. Let's make real moves in the direction for our species.
Parts. Because that's what I am. I'm a CNC machinist. I'm a guy that makes parts. They get assembled to rockets and submarines and race cars. I do it at half the price than most. And they blast off up to space to Mars under the ocean. And that's all I'm selling is I can make titanium, Inconel, Monel, you know, fiberglass, you know, carbon fiber, when it comes Delrin, Vespel, aluminum, you name it, we can make it on a CNC machine.
Now we take that CNC machining to 3D printing, we are unstoppable. We'll be trillionaires by 2030. Or we could continue to do debates.
That's one of my paintings.
We could just do debates, y'all.
You know, I have my own
let's do debates, or let's wait for young Pharaoh to come out with the next Black Woman is God and donate $1 to build a house so we could talk about aliens in the attic.
My grandfather from Washington was actually
or we could get Inky or let me pause it, man. Let me go with it. Let me do it. I didn't want to do it for 2018, but I'm gonna have to do it. Or we get Inky to talk about eating all the greatest high nutrient foods and going to Whole Foods and buying all the products that Dr. Sebi said from his laptop that he shouldn't even have knowledge of from the laptop. Who knows how he got that? But we could listen to them talk all day about eating right, eating good, and living long, but continuously complaining about the society that we live in. We're going wham about the society living. No, we just need to get right. We don't need money. We don't need none of these things. We just need to be right and call on the ancestors and chant and light up some incense and candles and prepare for the next debate about who can meta-netter the best out of all the meta-netters. Is it the priestly meta-netter or is it the scientific meta-netter? You know, no more debates, man. And that's why the brothers with the Aboriginal movement, it's really coming for a discussion so we can go over these things and establish something and see where we stand. We're trying to see where we stand so we can get something going where we're at. We can't go to another area without having something to bring. That's why you have to respect it. Honorable admiration to the 5,000 elite, Olmec Nation, Aboriginal family, and the Vortex Media family, because everyone else in the past they're going down. I don't know. I mean, I watch NBK. They're talking about tap dancing. Tap dancing. I'm talking about making everybody a trillionaire by 2030, and they're talking about tap dancing. I turn it on Signetter. Oh, Brother Reggie's challenging Jabari. I'm talking about making us trillionaires by 2030. They're talking about debating Kemetic priestly shrines or Kemetic science from papyrus that Reggie didn't make himself. We're going to sit and listen to this for another year. We're going to let this continue on. Y'all going to continue to look pathetic, begging for handouts, wanting, oh, we need reparations. We need our 40 acres and a mule. All you're going to do is get that and go buy the latest Ankh. You're going to go spend tens of thousands of dollars for the flyest Heru chain. Are you going to make a rap song that's all docile, sounding like you're sipping lean 24 hours a day? Or are we going to get the latest video from a person's couch in his mom's bedroom with a whole bunch of his pictures on the wall? Are we going to continue to do this? Are we going to make the right steps, man? The necessary things. I want to be able to walk into if we're going to continue on this path, and I'm going to continue to be on these things, and it's going to be involved with these the polites and the side netters, and there's really no one else really when you look at it. Who the Almond Raw squad? I mean, they're really not productive. So I can say, okay, the Flat Earth community, Brother Sanchez. I'm really calling everybody out, man. Are y'all going to continue to get out there, the Flat Earth community, to keep talking about NASA JPL and this is flat and it's not round? Are y'all going to step up to this right here and be some real men? Y'all going to continue to wait for the latest NASA rocket launch so you can have something to whine and complain about instead of you making the pieces that they use to launch the rocket to where you can charge them extra in order to trick you. Step up, be some men, and really get a solution going. And sitting there, and while you have people that approach you, like me, who sit around in these hangouts around you, who got on these live streams around y'all, and y'all want to ignore and push me to the side when none of y'all have real solutions. Y'all will continue to talk about this stuff for another 10 years if you want to. I feel like now that there shouldn't be no males out here talking on any of this stuff. It should be nothing but females, because really it seems like it's nothing but bitching going around in this community. Nobody's stepping up, getting a CNC machine shop, a 3D, 4D printing shop. Nobody wants to do these things. Everyone wants to sit and bicker and tell me about something in history. I don't want to hear his story. I want my story. My story starts right now. How do I get this $1 million to get these 3D printing machines so I can CNC machine and make the people who want to get along and want to do these things to become trillionaires? Not to become trillionaires just so you can have $1 trillion, but it means that you have $1 trillion that is consistently accumulated through a revenue. Doing these things for our people. And then the money, what will money really mean?
They look at the detail in the paintings.
You know?
They see, like, going into the surface underneath the rocks and stuff.
I don't even care about that.
Let me see if I can get it.
Like I don't care, man. Like me now, I don't even want to hear it anymore.
Looks sharp, but it's
now I'm gonna continue to finish
what is
exposing Cross-Repolo, Pigpen Cipher,
right? So I take people
and cryptography
through my when they
but I'd rather talk about this
because I'm about perfection.
I'd rather show this.
I'm not bragging. I'm just trying to give you the state of mind. People need to go on a journey. They need to know what you're about so they can believe in you. If you are perfect in all the things that you do, in your way, not perfect in their way, but you care, like my paint. I don't want a single splatter. I don't want anything. My rug matches.
And that's another thing too. No half-ass, and I don't even want to say that, but the N-word rigging. No more unprofessional, non-professional. I feel bad when I start my live streams and I don't have everything in order. That all ends tomorrow. So I'm tired of that. We need to have our stuff professional, a brand with style. You heard the man. You don't need to really hear him say too much more, because he got videos making things that'll blow your mind how much money he's getting paid
when a customer
to make them.
Sees that you have thought about these things, they're like,
right,
if I give him my work, he's going to care about.
All right, this is one side from my Matthew Craig channel, from my liked videos and my saved videos. Where we at? Okay, that's the last one. Let's get back. But that's what we need.
My name is Michael.
Come on, man. Excuse me. All right, my video ain't going through. Okay, so we really need to get with the program. Stop playing. Of course, I'm making my way to the mining. Nah, that's not it. That's more dealing with the world. So here we go.
I'm Becky Miller. I work at GE Aviation, and I'm a quality control engineer. Manufacturing is great because it lets you use your technical skills, your problem-solving skills, and your communication skills. And at the end of the day, I get to see a plane fly, and I know that I'm a part of that.
Hear that? You hear that? Making something, seeing it being used, knowing you are a part of that. Do you know how good that feels? You know how good I felt working on houses and stuff, and then seeing the family going in that house. Like, wow, you know, I helped build that whole portion over there. I helped lay the foundation for that. I helped lay the cement for their backyard. You know, it's like there's no better feeling that I have felt, you know, besides making a baby or whatever. But other than that, there's really no better feeling. And as men, I mean, I don't really see any other occupation besides being of authority, you know, security or some type of enforcement or I mean, that's about it. Any occupations we really should go for. And I know that for myself from being in the medical field, that even in the medical field, that's not a place for a man. That we really need to focus on these things, and office jobs too. Really recently had a bad experience with a company I worked with connected to Walmart, that even with that situation, that now it's to the point where if you're not Mexican, or if you don't walk around acting like you're a homosexual in these jobs now, they're going to get you removed. If you go into any of these jobs and you're not acting all dainty and rolling your eyes and all that stuff, if you carry your posture where you don't walk around like you're getting your butt popped, man, they are trying to get you out of there. And that's a fact in California. That's a fact in California. It's very difficult to hold a job if you're not a Mexican or if you don't act gay. Period. And it's a sickness that is going to be ended anyway. With 3D printing taking over, that's going to come to an end anyway. But the simple fact is, right now we need to survive. Right now, unfortunately, it's called survival, when we should be succeeding instead of surviving. You know, succeeding as a species instead of surviving to pay bills and going from check to check. You know, succeeding in securing a future for our people instead of succeeding in paying for a plane ticket to go watch a debate in Harlem. You know, or to go buy a plane ticket to go to Egypt and look at a wall and let somebody that's a foreigner to that country tell you what that is on the wall. No more of these things. Let's deal with these things instead of talk. And even with this, because eventually I'll get tired of talking about it and I'll just start showing me with videos working at companies doing these things. You know, and I have pictures and video footage from me doing demolition and construction in supermarkets.
Evendale, Ohio facility is GE Aviation headquarters. We do engine testing and development. We do manufacturing. We do assembly. We do sourcing. And we have our materials support team here, as well as our corporate headquarters. We make very large parts at GE Aviation. Some of our parts are as large as 72 inches in diameter. And on a part that large, even an error as small as 5 thousandths, which is about the size of human hair, can make a difference.
Yep.
I enjoy what I do every day. Every day I can go home and feel like I've accomplished something because there's always a new challenge for me to tackle. I think the false impression that people get about manufacturing is that they think that my job revolves strictly around machines or that I sit at my computer all day and analyze data. My job is actually very people-oriented. I work with groups of people every day to resolve problems.
See what it said? Now,
eventually, all day and analyze data. My job is actually very people-oriented.
Over 10 years, expected increase in demand for industrial engineers, less 20%. That would be a 20+% increase for assembly and installment, because all the other jobs are going to be taken over by machines and robots, y'all. I
work with groups of people every day to resolve problems. Even a small part can have a huge impact on the engine. This is a nut plate that goes on our low pressure turbine cases. This little part is so important that we decided we needed to do torque testing to make sure that this doesn't fail when our assemblers in North Carolina put the engine together. To get everyone to work together on a problem, typically I like to make sure everybody agrees that there is a problem. So an operator and the methods engineer, they have to work together, and if they both think that there's an error with our process, then it's a lot easier to go tackle that issue. I also perform product audits on our part. That is checking every characteristic of our material to make sure that our products are conforming when they go out the door every day.
Becky, this is a big part. What is this?
This is our low pressure turbine case. This contains nozzle segments and assembly. The tolerance on the wall thickness is about 10,000.
So a few human hairs.
Yeah, it's always.
They've expressed this too, while a lot of people were watching Housewives of whatever and BET Awards and VH1s and MTV this, that, and the third, a lot of the times I turned it on PBS, TLC, and I watch stuff like this. I'll fall asleep watching the BET or World Star fights and all that type of stuff. Even watching Sound Editor and them arguing debate, I'll fall asleep watching that. You put it on Animal Planet, Nat Geo, and stuff like this, I'll get up out of my dream just so I can watch this. This is what I want to see. I don't want to see no debates. You're gonna go fly to a place to go see a debate. I'd rather watch this so I can have the knowledge to make the parts to the very airplane that you're going to go fly and go see. And guess what 3D printing does? 3D printing makes this job 10 times easier.
And you have to control the size of the wall to that precision.
It's a structures case, so we got to make sure that at the end of the day, everything will fit inside of it and nothing can escape it if something were to go wrong. The whole quality system is based more on our tight tolerances. It's not so much to do with the large features of the part, it's all the little ones that actually matter.
I'm seeing sort of a shiny metal surface here, but I know it doesn't begin that way. What does this part look like when it comes?
It actually comes in as a very large black forging. So there's a few more inches of material. It's this basic shape, but doesn't have all these features in it.
What steps happen to get it to look like this?
It starts in our turning processes. The turning basically makes the thickness of the case, and it makes all these distinct features on the inside. After all the turning is done, it then goes to our milling operations, where we get our bolt holes put in, and then we have just a little bit of assembly on this part. Nozzle segments actually slide into these. And then that's important because the nozzle segments are supposed to be of a certain size, and we want to make sure that everything fits properly in assembly.
You are a quality engineer in the large parts area. Do you like that assignment, working on the big stuff?
I enjoy that our parts are so complicated because every day you see something different. We make these features on these machines every day, 2 to 3 parts a week, and you still see a challenge, at every step. And at the end of the day, I get to see a plane fly, and I know that I'm a part of that.
Next. No more debates, y'all. I'm done.
To live well, a nation must produce well. Manufacturing continues to be a mainstay of the American economy, accounting for nearly 20% of our gross domestic product and 17% of our nation's employment.
Soon to be 80 to 90%.
Increased global competition and economic realignment, U.S. manufacturers are turning to advanced technologies to maintain their edge. The result is a decline in the demand for manufacturing operators, fabricators, and laborers, but growth in the demand for specialty occupations such as engineers who understand the advanced manufacturing technologies. And Missouri S&T is Missouri's primary engineering school. In the past 5 years,
we have received over $20 million in manufacturing-related research funding from public and private sources. Several state-of-the-art manufacturing laboratories have been developed or enhanced, such as facilities for friction stir welding, virtual reality, water jet cutting, composite manufacturing, direct digital manufacturing of ceramics, the Material Research Center, and the Laser-Aided Manufacturing Processes or LAMP Lab. These top-notch research activities have also benefited our manufacturing curriculum. As a result, the Manufacturing Engineering program is an interdisciplinary program which includes advanced manufacturing processes, shop floor management, quality control, material processing curriculum, and facilities to provide a comprehensive and practical manufacturing education. Due to its interdisciplinary nature, a wide range of courses in manufacturing is available. These include lean manufacturing, CAD/CAM, rapid prototyping, rapid manufacturing, manufacturing management, and manufacturing automation. With student-to-teacher ratios much lower than most universities, getting personal attention is the rule. Over 95% of our Master of Science students receive an assistantship or fellowship to conduct advanced research in manufacturing, while many students pursue co-op and internship opportunities. In addition to the traditional class offering, our program has also successfully extended our curriculum to the world through distance learning. We offer a full master's degree program via the internet. All distance courses can be viewed at the student's convenience, live at the student's desk at work, or through archive delivery using file download. When combined with flexible scheduling, this benefits both student and employer. Our program is the only master degree program of its kind in Missouri and is among the first in the nation. Despite economic uncertainty, over 400 recruiters representing nearly 150 companies regularly come to Missouri S&T to recruit our graduates. S&T graduates are in high demand, with starting salaries among the highest in the nation. Employers regularly support working engineers pursuing the manufacturing degree or graduate certificates through distance education with tuition assistance. Missouri S&T's manufacturing engineering program is a field that is at the center of manufacturing. It includes engineering, materials, and management. It's where the action is and requires individuals who have a well-rounded education. Manufacturing engineering at Missouri S&T. Engineering tomorrow, today.
If you're putting your house on the market, this is a story you have to see. It could save you thousands of dollars. Here's our Nydia Hahn with details.
This new service is called UpNest, and the local guy who used it says it saved him a whopping $7.5 thousand. This is drone video of a...
Yep, good to hear that. Okay, this is how a microwave oven works, y'all.
This is the heart of the microwave oven, and it's called a magnetron, and essentially it consists of a vacuum chamber that contains a filament that's heated up by putting power on some two wires here to a point where it will emit electrons, and around this filament is an anode which is connected to these fins, which takes away the heat that doesn't get used into making power. And this end here is the power, the output. This connects into the cavity, which is essentially the oven. The waveguide, we call the oven a cavity. So that's what the heart of a microwave oven is. This is the power generator, very high frequency. But basically, the tube itself is simple. And here is if you cut away all the outsides, you see what I've done here is taken away all the outsides. And we have, again, the connections to this hot filament I was talking about, and we have the connection to take the power out. And then your question is, well, how does it make power? So we took one of these apart, and you can see what's inside of it. I was telling you about a filament. This filament has broken, but there's usually a spiral of tungsten or thoriated alloy tungsten connecting between this point and this little shell here. And that's the thing I was talking about getting hot. And the electrons that are emitted by that filament, when you put voltage between that filament and this anode, would ordinarily just zing right straight across and nothing would happen. But there's a magnet here. That's what this black thing is. It's a magnet. So when electrons start to move in one direction, the magnet turns them. And depending on the voltage, it turns faster or slower. So now we've got the electrons whirling around in a circle around this filament. And they're not going over to connect to this copper anode. Now you notice the anode isn't a solid piece of metal. It's got some veins. These are designed to be resonant at the frequency that we want. Resonance is like when you have a person on a swing and you want to make them go fast or higher, you push them at the right time, so each time you push, it goes faster. Instead of hitting them when they come back at you, you're going to stop them. The electrons go by each of these veins at a time such that they can kick another electron that's inside this copper at the right time, start building up a voltage. And that's what happens in the magnetron. Electrons whirl around at the right speed to generate a wave energy in a nanode, which is designed as a bunch of resonators. So now you've got this thing making microwaves, but you have to do something about getting the energy from there out. They go round and round at a speed such that they're essentially synchronous with the voltage, which is a high frequency voltage that's changing rapidly back and forth, essentially like a synchronous engine or motor would be. They're generating electric fields, which are stored in these veins, between the veins, as electromagnetic energy. That's a resonant cavity. Now, how do we get that power to come out to put it in an oven so we can use it? There is a cap on the end here and an insulator, and a small rod from this cap connects to one of these veins to connect the power out. And by mounting this,
and again, like the other videos, there's things I don't agree with.
Place is the nation's
but
#1 movie.
That's to explain what they don't understand.
Terrifying,
you know,
genius, dazzling.
Yeah, you know, instead of talking about this movie, A Quiet Place, man, that's deep. I don't have any time for it. I know the family want to talk about it. It's cool, but no more.
Crowded theater. A Quiet Place.
No more. Give me a loud place, a machining, a CNC
No one
place.
wants
Give me
a
that.
handmade engine block or jet turbine. We want precision things made by machines. Machine tools built our modern world. Our lifestyle wouldn't exist without them. Now, machine tools on modern marvels. Simply put, machine tools are power-driven machines of all shapes and sizes, primarily used to create metal parts. Those metal parts might be the steel mold for a plastic automobile headlight. They might be the aluminum supports for a jet airplane body. Or they might be parts to another machine tool. Machine tools have left their legacy, cut, stamped, and shaped into the metal of every imaginable product.
That produces thousands of parts that go into the makeup of various items that we utilize every day. If there's no machine tool, everything would have to be shaped by hand scraped, fitted, or filed into specific shape to fit into mating parts.
All these inventions that came about in the late 19th, early 20th century might not have come about as easily as they had if it were not for machine tools.
Machine tools are at their core tools. If you think about a tool like a hand drill, a machine tool takes that drill's process and mechanizes it, and performs it more precisely and more efficiently than a human ever could. The most widely used machine tools today are called machining centers. They perform a host of operations from drilling to milling to pouring. A raw block of metal goes in, a finished part comes out. One place where this began was the Cincinnati Screw and Tap Company, founded in 1884 by George Mueller and Fred Holtz. Today, the company they started is one of the world's leading machine tool manufacturers.
What we do here in Cincinnati is we design, manufacture, and assemble all of our machine tools built in the United States. This particular machine is called the U5 because it can operate on 5 sites of a part. And these days, our customers, in trying to reduce setup, they want to complete a part in one operation. Hence, they want to be able to operate on all 5 sides of the part. Typical customers of this kind of machine tool are tool and die manufacturers. The machine would come in and would actually shape the die, for example, in the shape of a door frame for a car. There are 2 Pentium microprocessors running the computer that runs this computer numerical control machine. The computer directs all the operations of the machine tool. There might be up to 50,000 unique tool points, all blended together in one motion. You can store literally hundreds of thousands of data points in a machine like this.
Wow, man. That's what I need.
This one starts at close to $1 million.
Y'all could have the latest camera, the latest $80,000 car. Give me that. See, you buy that $80,000 car and it devalues. You buy that camera and it devalues. I get this and I'm a trillionaire in 30 years. That's the point of this, man.
$1 million. And that price can quickly double as features are added. Also building the machine tool business was Parquet LeBlanc, which opened in Cincinnati in 1887 with just a handful of employees. Today, it's the Makino Company, one of the largest machine tool manufacturers in the world. Among other things, its tools make precision parts for the space shuttle program.
This is one of the stages of an impeller for the main shuttle engine. What happens is we take 3 of these, stack them together, and together they'll generate about 76,000 horsepower running at 36,000 RPM. This is a turbo pump for the oxygen on the main shuttle engine. It has the ability to drain a swimming pool, an Olympic-sized swimming pool, in 59 seconds.
The part is machined from a solid piece of titanium that can cost as much as $50,000. The machining center cuts it to precise, extremely complex specifications.
It takes about 13 or 14 days straight just to mill this part. So this is probably as difficult as it gets.
Machine tools are really extensions of man's most basic tools, the human hand and the human mind. Primitive forms of machine tools have been around for thousands of years. Crude bracelets were turned as early as 100 BC by the Latin Celts. There are drawings of sword grinders dating back to the Dark Ages. In the 1600s, sawmills and grist mills, early forms of machine tools, were built next to streams and powered by falling water. In the 1680s, Peter the Great collected simple machine tools that could decorate watches and trinkets. But the story of modern machine tools, those strong enough to shape heavy metal, begins with the Industrial Revolution in England in the 1700s. These tools depended upon a new source of power, steam. In 1765, James Watt created a steam engine, dependable enough to power a machine. His engine harnessed the up and down action of the piston and used it to turn a crankshaft,
a process called rotary power. Watt's rotating crankshaft would be what powered the first modern machine tools.
The real beauty of the steam engines, at least related to the machine industry, is that you could put a steam engine anywhere. You didn't need a water source. You didn't need a mill run to operate a wheel. You could put a steam engine of any size in your factory and do machining.
It was really an innovation to have a steam engine that could be hooked up almost anywhere. Steam engines, however, were difficult to run. They took a long time to get started. They had to be well lubricated. They were loud. Unfortunately, they were quite dirty. They were surely not safe.
In spite of their shortcomings, within 50 years of Watt's steam engine, all the basic modern machine tools would be invented, most of them powered by steam. Some would be adaptations of earlier woodworking tools. Some would be completely new ideas. The mid-1700s through the early 1900s would be the single greatest period of machine tool invention and design.
We think that we are so far advanced today, and we are so clever and so smart and have so much technology behind us, and yet the early people that devised the first machine tools really were very, very bright individuals. It was a by guess and by golly type of thing that eventually produced something of value. They didn't have the college degrees that are evident today, but by golly, they had a lot of ingenuity and they used it.
Machine tools changed the world by making possible the manufacture of all kinds of goods which prior to the Industrial Revolution had only been within the realm of the wealthy. Suddenly, they could be produced in vast quantities at low cost. The machine tools that made this possible can be broken down into 7 basic types. The earliest are the turning machines, also known as lathes and bores. The second were the planers and shapers, built to work with metal much like a carpenter's plane. Third was the most durable of all machine tools, the milling machine. Like the planer and shaper, it smooths and shapes metal parts. 4 other tools round out the 7: drilling machines, grinders, power saws, and large metal shaping tools known as punch presses. All were invented by men working with little more than intuition and a deadline. When we come back, we'll take a look at them.
We have a deadline, you guys. And it's not 2030, it's 2020. You need to get on the ball and these things going with before 2 years. You need to be up on this by 2020.
Tools will return on modern marvels.
Let me rephrase that.
It is difficult.
We need to do these things now.
In a single clear line. People invented.
You know, I want to say this. There is one thing that is guaranteed after being alive, that no matter what, you will die. No matter what. There's nothing you can do about it. Now, if you want to talk about some scientific advances and spirituality stuff, cool. Some scientific advances to make it to where we don't die, great. That would make existence boring. But hey, one thing is for certain, we will die. Are we really gonna die? Because most of us in this community, and I've seen the numbers of many different channels of the age groups and which gender is at a greater percentage of watching these different social media outlets on YouTube. And I find that between the age 25 and 40 is really the ages of those who are watching this conscious community stuff. And those 25 to 40, 75 years from now, we'll be dead. Okay? We will be dead. Are we going to let another 100 years go by? And we're going to continue to go down this? Because technology is getting better. Things are getting tighter. Trying to do things illegally is going to be impossible in 2 years. Get right with this now. Get with the 5,000 elite. Deal with this now. Get on board. Hop on board. I'm saying this personally to people. Even polite. You need to shake all that stuff you're doing, the bragging about that, and hop on board so you can redeem yourself. Hop on board. I understand people don't want to be feel like they're doing something wrong when they're doing the ultimate wrong because they're in a circle of people that are doing things that are far times worse. I understand that plight. But the days are over. It's time we move on. Now, I'm not going to show this microwave isolation.
Machine tools for the
I really got to get to the how things are made. There we go. Yeah, I'm not going to show the microwave stuff anymore because we basically get it. If you don't, there's no limit to the innovations that can be achieved pertaining to the microwave. Just the microwave alone.
To generate and to amplify radio waves with very high frequencies, so-called microwaves, special tubes are required. For example, the klystron. Consider a simple klystron amplifier. The essentials of this simple klystron are the electron beam, and two metal boxes known as cavity resonators. The cavity resonators have a potential which is positive with respect to the cathode. Thus, the electrons emitted by the cathode are accelerated towards the first resonator. Because the resonators have apertures in the form of grids, the electrons will continue until they reach the collector, which is at the same potential as the resonators. Therefore, in the region between the first resonator and the collector, the electrons would have a constant speed if it were not for the influence of the cavity resonators. In reality, the first cavity resonator is supplied with the weak high-frequency signal which is to be amplified. This signal will initiate an electromagnetic field inside the cavity. Due to this field, the velocities of the electrons passing through the first resonator are modulated. On arriving at the second resonator, the electrons will induce there another electromagnetic field of the same frequency. This field is so strong that it is possible to extract a large signal from the second cavity. To understand this amplification process, it is necessary to study the behavior of a cavity resonator in detail. There is a certain similarity between a cavity resonator and a conventional resonant circuit. A simple resonant circuit consists of a capacitor and an inductive loop. It is known that a conductor contains free electrons. Charging the capacitor to obtain a voltage of this polarity means that many electrons are removed from the upper plate and an equal number of electrons are introduced into the lower plate. Thus, there are two charged layers. One layer has an excess of electrons and is therefore negatively charged. The other layer has a shortage of electrons, which reveals itself as a positive charge. The electric field lines are directed away from the positive charge. If the capacitor is charged with a reverse polarity, the direction of the field lines is also reversed. The displacement of electrons in the loop constitutes an alternating electron current, which is symbolized by the variations of the green arrow. The alternating current gives rise to an alternating magnetic field. The magnetic field of the loop is out of phase with the electric field of the capacitor. At the moment that the magnetic field is at maximum strength, the electric field is zero. A quarter of a cycle later, when the electric field is at maximum strength, the magnetic field is zero. There are two similar situations in one cycle at which the fields have the reverse direction.
All right, let's get to another part. This is a
Thus,
long
the oscillation, which was started by loading the capacitor, represents a certain amount of energy that is continuously exchanged between the electric field and the magnetic field.
But that's
The
just
smaller the value of the capacitor and the inductivity of the loop, the higher the frequency of the oscillation, or the resonant frequency. With this simple circuit, a rather high frequency can be obtained because the inductance of a single loop is very small. To obtain higher frequencies still, the inductance can be further reduced by placing two or more loops in parallel.
exactly. Now
This
you can see
results
the.
finally in the formation of a
I'm gonna go to the next video, but now that's just to show you how that works.
I just have one quick question. You know, we hear that maybe 1,000 times a day, and if we didn't, I think each and every
Man, he looked like one of them aliens young Pharaoh be talking about.
one of us would concern us, because that's what we're there for.
Okay. 3.5 years ago, I was conducting aerodynamics research at a wind tunnel. And through that research, we were able to significantly enhance the capabilities of wings. The machine shop was integral to that process because I had to basically build and then test and build and test and build and test.
You know what?
Our project this semester is an automatic.
You know, one thing I noticed in all these machining facilities, I don't see any brothers and sisters. We too bad trying to be athletes, trying to be musicians, trying to sing and rap. We're too busy doing that. We're too busy working the job that we're expected to work, the job that has been picked for us. You know, that's manifested our destinies. These jobs have been picked for us. And sad to say, in California, in the machining business, is going to be upon how well you do your job. But in California, man, when you deal with these companies that are dealing with warehouse or construction and stuff, you are literally at the mercy of another race of people that don't want you working there. And I'm gonna call it out right now. In California, The Mexicans will make sure you are fired. As I said earlier, if you're not acting dainty like a homosexual male or effeminate male, if you don't come in here acting like a metrosexual, and you're a man, and you know everything about you is a man, you are going to have issues at that company. You know, and I'm a nonconformist when it comes to that. So I'm not going to conform and act all feminine and dainty like the men around me in some little weak, pathetic office job that machines can handle. And this what the future right now, 2020, I'm telling you, it's going to cut out fast food, all this fast food stuff where you're dealing with workers messing up your order and stuff. I really feel you should eat fast food anyway. But if you notice that big time cities, it's like we're not there. We're not there in the public stuff because we're getting fired, because people want us fired because they don't want us there. We're not in these machining warehouses working at these companies because we want to be rappers and singers and athletes. You know, what else is popular for us to be? Oh, okay. You could be a YouTube mogul. And if you're lucky, you could become big and start scamming people, you know, and make your money, because really there's no future in that. And instead of these things, we could have facilities where you walk into it and it's a 3D printing facility and all you see is our brothers and sisters. Could you imagine having a video where we're going into a facility and you see Ty Data and Q Butter and and Eric Thomas and you know what I'm saying, people who are like really about this, you know? I'm trying to think of any other names of people who are really about this, you know? Hey, it ain't too many. Ain't too many that I've seen that are really showing and proving that they're really about this, you know? I mean, with Umar Johnson's situation, Umar, you still have all that money, you know, stop playing with us, man. Put that $100,000 on that 3D printing machine, make yourself a trillionaire. Why is it that I have the plan and the solutions, but he has the money? It blows my mind. But that's because we want to see singers, we want to see rappers, we want to see athletes, we want to see the flyest person, we want to see the person that can talk the smoothest and manipulate us the best, the person that can make us say, yeah, that's right. Black power, put your fists up. That's what we want. We don't want this. We don't want 3D printing. But so what I'm going to do is it took me a while to develop mine, manufacture, and mass produce philosophically. But with the GoFundMe, it can be possible. And again, 3MP, tomorrow on 3MP TV is just a tool for the 5,000 elite, to be honest. That's really what it's here for. I am for what's right, what works, and a proper solution for our people. And nobody else is putting up a proper solution. So therefore, I'm taking it upon myself to start really showing what we should have done a long time ago. Instead of trying to watch videos about we were Kongs and we were the great Egyptians or anything in history, we should have been on this. We should have studied Booker T. Washington and saw what he meant by saying 72 trades. That a man should know how to do all these things with his hand. Every man should know, every man in our species should know how to do everything that every man knows how to do. Now, when it comes to different sides of the brains, is like art, stuff like that might not be for everybody, but you know what's going to work for every man unless he only has one hand or one foot? Mine, manufacture, mass produce everything we use. No way around it. We have a lot of homeless people out here. Get round up our brothers and sisters that are homeless. Get 3D print them some homes, and they don't have to put them to work. But what else are they doing? Let's stop wasting our time buying all these shoes that cost $200, $300, buying all these clothes and 3D print them for ourselves. Let's do these things now. Let's not wait. Let's link up with the
guitar tuner and player.
Those who have connections.
So we have 6 servo motors down here that are in charge of plucking the strings, and 6 servo motors up here attached to tuning attachments, which automatically turn the pegs for you.
Look at this.
Convinced in engineering.
I respect what this female is doing more than what Reggie and Jabari and all of them are talking about on HOK right now. But that's small side of it. I'm talking about what's talked about on Oprah Winfrey Network. She should have nothing but this. Nothing but this. No. MTV, BET, and all this other stuff. And the colleges or this video footage of a live thing, or what is it called? Real TV. What is it? Who knows? Who cares? But anyway, all these different things, these housewives of this. And like, I'm done, man. We're not going to go anywhere. But enough of that. That's putting it down. Here goes the upliftment. Children from the age of 3 to 7, as a little boy, when they see something shiny, they want to touch it. They want to feel it. They want to know how it works. Start teaching at that age. Start giving our 3 to 7-year-olds the tools and the mind to use their hands to build, to want to use 3D printing machines, to want to assembly and install. The future jobs are going to be in assemblage and installments. That's it. That's it. There's a change coming, and this is not no prophecy. These are laws that are being passed right now on C-SPAN 1, 2, 3, 4, and as many C-SPANs as there are. We're not paying attention to the things that we should. Instead, we're getting caught up on many things that are just distractions. So I'm here to keep us on track. That's what I'm here for.
The bulk of the creativity for these things comes from the engineering innovations that occur because of people having exposures to places like the machine shop, where they can see this sandbox of creative capability.
Learning by doing is probably one of the most essential experiences you're going to get in here.
Learning by doing.
The theoretical that you learn in
Learn your
the
books.
classroom with the practical of how it's done out in industry.
It's easy to, in your CAD program, to make everything that it has 5 decimal places of tolerance, but for them to actually physically go in the shop and try to meet that standard, it gives them a whole new appreciation for kind of the physical reality of it.
So there are a few parts that I had to machine within a 0.5 to 1,000th precision. There's no real way to calculate that. It comes down to a lot of touching and feeling and experience.
You become immersed in.
So I know everyone pretty much gets the point on this. I need to
I think for
I
a
need
lot
to close
of
it
our
out.
engineering students, it may be the first
let's
time they ever
close it out, right?
experience that physical contact with what they're making, and you can see it in their eyes.
Keep going. Real fine tolerances and real fine sizes, sneak up on it so we don't go past it. Getting down into
Close
the
it out
shop
with
here,
a
working
few
with those
videos.
materials is really
I need to show you this video. It's a very important video. Something that blew my mind, because I would listen to people talk about these things, and they really don't know what they're talking about.
They help run motors and generators, among other things. Magnets occur in nature, but 2 centuries ago, people figured out how to make them using electricity. You could say.
Now, they said magnets work in nature. Yeah, but in what way? Is there something that's natural? Like I could walk past a piece of rock, and I'm walking past it, and whatever metal I have, I'm going to fly to that piece of rock. Is it natural? See, there's something they're not telling us about it, but they're going to show you here that magnets are not quite what we thought they were. And they are the key working parts to many different things, and in very, very important machines that we use today.
It was a take charge situation. You can't see or feel the force causing this globe to levitate, but it's not magic, it's magnetic. To make magnets, they must first create a sand mold of the magnet shapes. They load this pattern of 4 magnet shapes into a machine that fills it with sand. They remove the pattern and smooth the surface, dimpled by the machine's lid. Then it's back inside, but this time, the machine pumps in gases to chemically harden the sand. It takes just seconds to solidify. They lift out the sand slab, revealing the impression of the magnet pattern. It's now a mold. Magnets come in many shapes and sizes, as do their molds. Now they're ready to mold the magnet shapes. They take copper, cobalt, sulfur, nickel, pure iron, aluminum, and titanium.
See how many different minerals it takes to make a magnet? Are you telling me there's a rock that's made up of all that stuff that if I walk past, I'm going to fly to it because of metals? I'm telling you, and even with that stuff they're saying about those electrons and stuff, those aren't electrons. But this is not about that. That's why we need to get a hold of these things and start doing it so we can explain it from experience, because a lot of the philosophies that are tied to these things are lies. But you know what's real about it? The fact that they can take those minerals and put them all in one and do this.
They load all these metals into an electrical induction furnace. It generates a pulsating electromagnetic field that heats to more than 1600 degrees Celsius, melting everything into a molten soup.
You see that? Now me, I love doing
this. They pour it into the sand molds. The molds burst into flames because the gases that harden the sand are highly flammable. They slide the blazing molds to another part of the foundry and knock them to the floor. Then they bust them open with a sledgehammer to get air inside so they cool down and the gases burn off. They shovel everything into a bin and sort the metal shapes from the sand chunks using, what else? A magnet.
Yeah.
The molded pieces react like ordinary metal. They don't yet have magnetic power.
You hear that?
Some are shaped like rings. Threaded onto a copper pipe, they'll be used in electric motors. They place the ring-covered pipe in a much larger tube. Then they center it by packing silica sand tightly around it. The sand will hold the rings in position during the next step. They seal both ends with concrete, allowing the inner copper tube to protrude slightly. Then it's into another electrical furnace. It heats the tube full of magnet shapes until it's red hot. This primes them to accept an electromagnetic field, which will be delivered by this metal rod. They slide it down the center of the copper pipe and clamp it in place. Water keeps the pipe from melting as they deliver a low voltage, high current charge in a cylindrical formation, important for motor magnets. They break open the seal. The process has left the ring shapes mildly magnetized, but most importantly, it's oriented the magnetic field properly. They grind away any rough edges. At this point, all magnets are pretty useless.
Wow.
But this machine will empower them. It delivers an electromagnetic charge to the metal, which magnetizes it.
It's so funny. One would think they knew something about magnets. We've been using them since kids in preschool and kindergarten, but turns out it's not quite what those textbooks told us.
The establishment of that weak magnetic field earlier has laid the groundwork for this moment, ensuring that the magnetization is properly oriented.
That's how it's polarized. It's electrically
now that's
charged.
Some serious magnetic muscle. In their various forms, magnets continue to exert a lot of pull in our society because their invisible power helps keep so many things running. is the hind leg of a pig. You can buy it raw or...
Okay. Now I got one more video and then I'm gonna have to close out, man. I truly appreciate the family in the chat. Give an honorable admiration to the family for taking time. Of course, Brother Root Words. We have Jerome, 4,445. Tribe BAB in the building. Mark Falk, as always. You know, thank you so much for y'all taking y'all time, man. Before we close out, you know, it's something that's connected to magnets that I'm going to show you now. Trying to find a decent one. Oh, come on, you know. See, you can make homemade ones, but I'm trying to find the one that's in the actual shop. I see one already. And of course, when it comes to free energy, you see Tesla's name popping up. But okay, let me get to this one video. So we can have 3D printers print solar panels that gives us energy. Also, 3D print all the things needed to make free energy. And it just so happens, magnets is a key component to this. There's another video that shows even more. It actually shows a machine. All right, come on. Now there's engines that run on water. We have these free energy devices. We have 3D, 4D printers. This is all here for us to utilize today, right now. Look, and that's all you have to do to get it started. That's it. Get a machine to do it when you just need to push this push-up button. Now, I don't want us to be like the movie WALL-E where everyone gets fat because everything's so simple. So obviously, but with all the extra time that we have from everything that we spend all this money and work so hard to have, will just be so much cheaper to have, so much more reliable, and so much faster that, hey, let's get it. Let's do it. Let's do it now. We should have a 3D printing machine, a free energy machine at our disposal. More debates. Well, if we're going to debate, let's see who can make the best free energy device. Let's see who can make the best 3D printer. If we want to debate so much, to show how at odds and disenfranchised and uncorporated and discombobulated we are by debating about things in a land that we don't even live in. Don't even acknowledge the people that are from there. Let's talk about these things. Let's make this happen. See that? Cut your power off. Can't debate on camera no more YouTube. Wi-Fi ain't gonna work. Free energy. Look at that. All right. All right. Way or impractical or innovate the rest of your life. I'm here for y'all. Hopefully y'all can help me. Like, subscribe, and share. Without doubt, donate to the 3MP. The goal is to take care of these things so we will be able to manufacture, mass produce everything we use. Thank you for taking your time. Tomorrow in the morning, we're gonna go in on some things. Oh yeah. Tomorrow morning at 8 West Coast time, Pacific. What's that? 11 East Coast time. So in the morning, I will definitely go even further in on this subject and topic. So thank you very much for taking your time. Truly appreciate it. Truly appreciate it, family. Peace.